Hey there, Charger people. It's Mrs. Boyd. Today, we're going to talk about compound inequalities. We're going to start out with or and going to move to and. So, compound inequality that has or is different, obviously, than one that has and we're going to graph it differently, and the problems will look different. So, let's get started with what that might look like. X is less than 4 is our first or scenario one. Let's graph that on the top line here. Less than gives us an empty circle. We shade it in the left direction. Greater than or equal to 6 is going to be a dot on 6, and we shade in the right direction. So the compound inequality of these two will be where they overlap. So, well, these are never going to overlap. So we're just going to put these two graphs together. So this top line, x is less than 4, and x is greater than or equal to 6, all on one graph. So this is our solution. The set builder notation is going to look like x given that x is less than 4, or x is greater than or equal to 6. All right, that's scenario numero uno. Number 2, we've got x is greater than or equal to 4, so we'll have a dot on 4, and we'll shade to the right. X is greater than 6, empty circle on 6, and we'll shade to the right. Well, if we want it to be greater than or equal to 4 or greater than 6, 6 is greater than 4. So all we have to graph on our final solution number line is the top graph, because it includes both the first and the second graph. So our set builder notation will just be x given that x is greater than or equal to 4, because x is already included in that solution. Last one of the or scenarios. We've got x is greater than 4. It's going to go towards the right. And we also have x is less than or equal to 6. So we have a dot on 6 and shade to the left. Well, if we put these together, they overlap here, right? They're both shading on 6 and 5. So that means we're going to be able to shade the whole line. That means there is no number on this line that would make it untrue. So our set builder notation, that's the worst bracket ever. That's not much better, but oh well. X given that, all real numbers, is a solution, because anything is greater than 4 or less than or equal to 6. Now let's flip your paper over and go through some story problems, some word problems, so that we can put the new symbols and compound inequalities that we just talked about into practice, real world style. First, to get a discount at the diner, you must either be less than 10. So our first inequality is going to be less than 10, or at least 55 years old. So greater than or equal to 55. So it looks like we're going to be less than 10 and greater than or equal to 55. Set builder notation is x given that x is less than 10 or x is greater than or equal to 55, because those don't overlap. Goes one way or the other. Let's try another one. You may be in a medical emergency if your heart rate is less than 40 beats per minute or higher than 100 beats per minute. So we'll do less than 40, more than 100, because those don't overlap anywhere. we include those both in our set builder notation. X is less than 40 or X is greater than 100. Moving on. To get an A in this class, your next quiz needs to be at least an 80. So X has to be greater than or equal to 80 or above a 90. X is greater than 90. Well, 90 is greater than 80. So all we have to include on our graph is greater than or equal to 80. That's also going to be the only thing that we include in our set builder notation. Next, for it to start snowing, the temperature needs to be less than or equal to 32 or less than 30. Well, 30 is already less than 32. So that's all we need to include less than or equal to 32. And that's all we need to include in our set builder notation as well. One more of these. Oh, two more, so sorry. I will eat any pizza as long as it has more than 2 toppings on it. So X has to be greater than 2, or it has to have less than 4 toppings. Well, if we think about this, 4 is greater than 2, and 2 is greater than 4. So it looks like we'll be able to shade any number along our graph, our number line. Doesn't matter how many toppings, we like them all. My R is not too neat. Let's fix that. So all real numbers, don't forget 2 lines with an R over them. All right, last problem about or inequalities. Your chances of winning a prize are great if I say pick a number out of a hat. You win if the number is at least 7, so X is greater than or equal to 7, or less than 10. X is less than 10. Well, 7's less than 10, and 10's greater than 7. So it looks like it doesn't matter what we pull out of the hat, we will be winning with this setup. So that is all about or inequalities. It's the 2 graphs together on one number line. They both have to be represented, one or the other. Now, the difference from and is that we have to include where these overlap, and that's the only place. So scenario number 1, X is greater than 4. All right, so that's going to be a circle on 4, and we shade to the right. And X is less than or equal to 6. So dot on 6, shade to the left. So these overlap right here. So what we're going to do to draw our solution is put the 2 endpoints and then shade between them. And that's the solution. So we've done this already in the past. Our set builder notation, only for an and inequality is possible. We're going to put the smallest number first, and our variable, and then the biggest number, and then the signs go between them. All the signs have to face the same direction. So this one gets to stay the same, and this one we need to flip around. Remember, if we do that, the number and the variable change spots. It's pointing at the 4, so it has to stay pointing at 4. And this is our solution. X, given that, 4 is less than X is less than or equal to 6. And it represents just this spot in between the 2 endpoints. Scenario number 2, X is greater than or equal to 4. Well, the circle on 4, and we shade to the right, and X is greater than 6. Circle on 6, shade to the right. These only overlap starting at 6. So since this is an and scenario, we have to only shade where they overlap. So that is essentially just what the bottom inequality shows. So our set builder notation, X given that, X is greater than 6 is all we can show. Last scenario here, x is less than 4, circle on 4, shade to the left. X is greater than 6. It's going to be a circle on 6 and shade to the right. These overlap nowhere. Impossible. So this set builder notation, oh my, it gets worse as we go. X given that, there is no solution. We don't shade anything on our line. There is nowhere, no number that's both less than 4 and greater than 6. Let's do a few examples of this, and then I'll send you on your way. Number 1, to participate in the Secret Santa, you must buy a gift for more than $15. So X has to be greater than 15. And it must be no more than, so less than or equal to, 25. So looks like we've got endpoints at 15 and 25, a circle at 15, a dot at 25, and we shade in between. Set builder notation, remember, gosh, set builder notation, our smallest number, variable, biggest number, same signs as we had in our original problem. And that's the solution. Let's try another. To go on a roller coaster, you must be at least 4 feet tall. So X has to be greater than or equal to 4. And less than 7 feet tall. So less than 7. So it looks like we've got endpoints on 4 and 7. And we're going to shade between those. 5, if we think about it, is right here, is both more than 4 and less than 7. Set builder notation, 4 less than or equal to X less than 7. To get an A in this class, your next quiz grade needs to be at least an 80. So X has to be greater than or equal to 80 and above a 90. So the only numbers that are greater than 80 and greater than 90 are numbers that are greater than 90. So our set builder notation, X given that X is greater than 90. Few more. For it to start snowing, the temperature needs to be less than or equal to 32, less than or equal to 32, and less than 30. Well, the only numbers less than 30 and less than 32 are less than 30. So that's the only solution we can graph, and that's the only thing that goes in our set builder notation. 2 more. I will eat any toppings on my pizza as long as it has less than 2 toppings on it. So X is less than 2 and more than 4. X is greater than 4. There is absolutely no number nowhere that is both less than 2 and greater than 4. So, oh, it's bad every time. So our set builder notation is no solution. Last, but certainly not least, your chances of winning a prize are not great if I say pick a number out of a hat. You win if the number is at least 8, so X is greater than or equal to 8, and less than 5. Again, no number exists that's both less than 5 and greater than 8. So our set builder notation has no solution. Our graph has nothing graphed on it. I hope you can easily see the difference between these two. I hope you're able to graph them, and I hope you know when you need to reach out for some help, because I'm here for you. All right? Take care of yourselves, and I hope to see you so soon.